Carbon monoxide detectors are a device that has a limited lifespan of 5 to 7 years. After that, they should be replaced because their efficiency drops. I have one here that's probably closer to 30 years old. We're going to tear it down and see what makes this thing tick.
I don't even need to tell you guys what this is, but when it was new, it was white. This is a very old carbon monoxide detector that's been kicking around here, sucking away 7 watts for the last, I don't know, this is probably, I'm going to say probably 30 years old or pretty darn close to it. It's long past its expiry date. I mean, these things are typically only good for maybe 7 years. But it was forgotten plugged in an outlet that was just kind of just sitting there. I've got a much newer one, even though I don't need a CO detector really in my house because I have a heat pump system. This was installed in the house before when I was using an old gas furnace that we thought might break down any day. But you know, we rebuilt the house in 2002, and this really hasn't been an issue because I don't use gas to heat the house. So we have a gas stove. So that could produce some carbon monoxide, but you know, not like a furnace would if you had a cracked manifold, for example, or a fireplace. And we haven't had a fireplace since 2002. It's been gas, direct vent. But this thing was found plugged in, and I just found the thing. It's been sitting there all these years, and I thought, you know, this thing's long since expired, and we're going to take it apart, see what's inside this old beast. This one was assembled in Mexico. I don't even know what brand it was, but it's pretty old. I know my newer unit actually has a display on the front, and from the time you activate it, it actually has a timer that counts. I think it's 7 years, either 7 or 10 years. It'll come up on the display and say off or old, or I think it says off on the display when it's expired, or EXP or something. It comes up on the digital display to tell you that it's time to replace it. So this is going to get recycled, but I'm going to take it apart and show you guys what's inside it first. Well, there's maybe some things I might be able to keep, like a power transformer and a regulator. I think we might be keeping parts out of this thing. Power transformer's not going to break down, that's for sure. It's got the, I guess this is the chemical ionizing chamber right here. However these things work. We'll take this off and take it apart. And it's just got a regular buzzer, right? And I would imagine how these work is that, you know, as the detector detects carbon monoxide through the little window on the front, I don't even know how it gets that. Where is that? It sits in like this. I guess the CO must travel up through the vents is what it does. Carbon monoxide enters through here because this is for the alarm, this one. Carbon monoxide would enter through the base and just through convection, because you see the way they've designed this is kind of ingenious, and I'm sure they probably all use a similar design, but you've got the transformer in the top, and you've got the regulator here, linear regulator producing heat, which is directly above the sensing chamber. So what that does is just through convection, this is actually quite ingenious. Air is drawn in through the vents on the bottom, which air then has to travel up over the sensor in order to cool the heat sink, and then the warm air exits from the top, and that's how these things work. And this screen here just keeps any dust and debris from getting into the sensor. But actually quite the ingenious design. And this shield around here is designed to keep the air circulating through and exiting through the back vents. Just the way it's designed, like that. So your air goes in. It'll go up both sides of the circuit board, it looks like, because I can see light through the other side, but enough of it's going to get pulled around, and because of the heat generated on this side, hot air is going to rise. It's going to create negative pressure below it, and the air is going to get pulled up over the sensing element. And we can power this thing up, see if I can make it buzz. I know I can by pushing the button, if the buzzer even still works. Let's get a 120 volt outlet handy. this little short 2-foot power cord. These are the cords you buy for when your freezer is just a foot or so short from reaching the outlet, right? I've actually got even shorter ones. I got 1 foot. I got a 1 foot patch cord, or 1 foot extension cord for my ceiling fan. Does this buzz still? Yep. So that part works. 15 volts, 5 volts. So it's a 5-volt regulator, so you'll keep that. And 5 volts goes into the power of the circuit. This is ground right there. So 5 volts on here, 1.4 volt on that side, 5 volts on this side, 1.4. So both of those are fed right off of the regulator, which they are. You can see the 5-volt line coming into here, onto this one, and looks like it's going through a transistor here to feed this side. I don't know which one of these controls the alarm, but I'm thinking it's probably this side because this goes into this IC. Let's see what this IC is. Interesting. Under all that paint is the actual number of the chip. It's a Motorola MC68HC705J1A. And that's a member of the Motorola's low-cost, high-performance MC68HC05 family. It's an 8-bit microcontroller. And it's a family based on the customer specified integrated circuits, CSIC design strategy. They're all based around the 68HC05 central processor and available with a variety of subsystems, memory sizes, and so forth. So it's the chip that was ordered. This one here includes 1240 bytes of erasable programmable read-only memory, and it's in a package without a transparent window for EEPROM erasure. And it's the 1240 bytes of EEPROM bytes serve as a one-time programmable read-only memory. So basically, these chips are supplied blank, and the customer loads their own firmware on it. But once the firmware is loaded, it can't be erased. There were versions that they had that had the window on them that you could expose to UV and erase it. But not this one. And of course, then there's double EEPROM, which was electrically erasable, programmable, read-only memory. It uses the resistor capacitor oscillator, and I'm just looking at the data sheet on it here. We can look at the design, the block diagram of the chip. So you've got an internal oscillator, a timer system, a watchdog, and illegal address detect. And then you've got your 1240 bytes of user EEPROM. So that's a block diagram of the chip. Here's some of the specifications of the chip itself. It has a 15-stage multifunctional timer, a computer operating properly watchdog, so it's going to check its operation. 14 bidirectional input-output lines, including a 10 milliamp sync capability and 4 input-output pins on 4 input-output pins. You guys can read this. Mask option register and software programmable pin pull down on all the pins. All the input-output pins, I should say. on-chip oscillator using a ceramic resonator, so no crystal required. 1240 bytes of EEPROM, one-time programmable PROM, basically. I think this probably refers to the two different versions of the chip. The EEPROM would be erasable, programmable, read-only memory, which would have the window that a UV light could be shone through to erase the chip. And in this particular one, this one is the one-time programmable read-only memory, because you can't erase it. There's no way to do that. 64 bytes of user random access memory. 64 bytes. It doesn't have much. And that's pretty much it. What else is there on here? Here's some of our features. You guys can read that. Pin assignments. So here's our pin out. So it could be driven by a crystal or a ceramic oscillator, or ceramic resonator, or resistor capacitor oscillator. So there's many ways that this can be driven. I think this is a ceramic oscillator, but 4 megahertz. But you can use a crystal or a ceramic oscillator or a resistor capacitor network. Basically, what this is doing, it's just watching the output from this detector. And when the detector starts to detect carbon monoxide, the voltage is going to change on its output, which is going to one of the input pins. And basically what it's going to do is it's going to start a timer. And if that input stays in an alarm state for a period of time, it's then going to sound the alarm. Carbon monoxide detectors are not fast operating devices. First of all, they wait for the buildup to get to a certain level, 100 parts per million or whatever the threshold is that the alarm is going to sound at. But not only do they wait until the concentration gets to that level where it is programmed to sound the alarm, but it also has to maintain that level for a period of time. And then the alarm sounds. And the reason for that is there are times where you might get a whiff of carbon monoxide. Like, you know, if you got your window open and someone's got a car idling and the car exhaust drifts into your home, that's typically not going to be hazardous unless it builds up for a period of time. Right? Or if someone's mowing their lawn with a gas lawnmower and the window's open. You don't want your carbon monoxide detector going off. You know, if there's an exposure in the house for 5 minutes and then it drops off. This is designed to go off if there's a buildup that continues to build up. So basically what they're using this for is a timer, is what it boils down to. It's monitoring the output from the detector, so voltage would be applied to the input. Here's the output side here. The output side you can see right here. Find something to point with. So we've got power going in, 5 volts goes in here. This is going to be a regulator of some type, maybe a switch to turn it on and off. That's reset from an output on the microcontroller. Because it looks like this is a transistor here. The 5 volts comes in, and then it goes through a transistor. The transistor, this is the base from the collector of another transistor. It looks like, is that another transistor? Anyway, that's going to toggle the power on and off to the sensor. The detection side over here is fed in, and it goes in through a resistor here. That's a resistor there, and it goes into one of the input pins. But basically, this device is just being used as a timer. It monitors the level, so it's probably set because this is going to be a linear device. So the stronger the concentration, the higher the voltage is going to be on the output from this device. And when the voltage gets beyond a certain voltage range, which is programmed in, so this can monitor the incoming voltage. When the voltage gets beyond a certain point, it then starts a timer counting, and if the voltage doesn't drop off before the timer expires, it turns on the buzzer. I think that's pretty much sums it up. We're going to pull this piece out and take it apart and see what goes on inside that. Everything else we know they're just basic other components, transistors and diodes and capacitors and resistors. The only thing on this thing that's kind of unique is this module. So let's take the module apart, unsolder it from the board here. And we'll see what's inside it. And then this thing, I'm going to recycle it. Well, I'll pull the transformer and I'll pull the regulator and stuff off that I can use, because it's always good to have a 5-volt regulator kicking around, right? So, and a little 15-volt transformer can also come in handy. So before I recycle the rest of this unit, I will keep the parts that I can certainly utilize. They sure do not skimp on the solder on this, that's for sure. Let's open that module up and see what's inside this thing. The easiest way to get in this is probably through the screen at the top. I don't think I have to worry about any radioactive devices in this. It's not like it's a smoke detector. Smoke detector, you wouldn't want to be opening up the detection. At least an ionizing type, you wouldn't want to be opening up the detection module because it has radioactive material in it. But this is all chemical. These work with chemical detectors. That's why they're only good for, for 5 to 7 years, as they say. Is the average life for one of these units, and this one here is well beyond that. What do we have here? Almost looks like carbon. And then there's another screen. And here's another screen below here. Interesting. Oh, that comes off. Okay. Could have probably just popped that bottom ring off and pulled the whole guts out, but then we wouldn't have found this. So it had this black, and it looks just like a piece of almost like, it feels like it's made out of carbon. It's probably conductive. Let's just check it with the home meter. But if I put the meter on here, this stuff is conductive. You see? What's inside this one? Is this just hollow, or is there something else under this screen? Let's find out. It's funny, I normally don't answer the home phone because it's never for me. And today I answered it and I got some good news. So that was my financial planner calling to tell me that I'm richer than I thought. No, it wasn't anything like that. I wish I'd won the lottery. No, it was just one of my accounts was coming up for renewal, and of course right now interest rates aren't very good, so I was just getting options to earn an extra half a point. So I see all these ads for these self-directed ones, and as opposed to having a managed account, and my managers have always done good. I've always done well with them. There's another screen inside here. This is interesting. 2 screens in a row. You see what you guys are learning? When you look inside one of these things, what's actually inside one? I had no idea what's in here, but this is all wrapped up in another screen. There's got to be something under here. I would think it would be the detection element. I don't know what the purpose of this was, maybe to filter it. But under here, I can certainly see something inside here, and it's really well protected under these stainless steel screens. It's like, wow. And this is it. This is the detection element. For those inquiring minds that want to see what it looks like, here's your chance. I would imagine that all the screening that's on here is to try to keep this thing from getting any dust on it, and to try to keep the environment in here as clean as possible. Because I'm sure any smoke or any like cigarette smoke or any other type of combustible smoke that would get on here probably would contaminate it. So I would imagine that that's what all the whole point of this screening and this carbon filter, right? Carbon, of course, charcoal. I'm sure that's what this is. Removes contaminants, removes absorbs any other type of gases but allows the carbon monoxide to filter through. I would think that's what all these screens are about. Is they go smaller and smaller. So you've got this screen. Well, we first had this screen on front, and then we had this carbon filter below it, and then there was 2 more screens. I just stuck myself with a bit of stainless steel wire here. Stuff's sharp. 2 more filters underneath it with just this little detector, whatever that is made out of. It's obviously made out of a chemical that reacts and changes its resistance to the presence of carbon monoxide. It's just suspended by its little wires. I'll clip off the wires and take a look on the back side of it. Anyway, that's about all there is to this thing. I can now toss the rest of this out. And we'll remove the components I'm going to keep. So what I will keep off of this is obviously the capacitors I'm not going to keep because they're going to be shot anyway after all this time. I'm going to keep the regulator. I'm going to keep the transistors because you never know when you're going to need a small signal transistor, and they always can come in handy to fix anything, like from an amplifier to pretty much anything. So transistors are always good to keep. Small signal transistors, and they're easy enough to take out of the board. So we'll pull the transistors out, pull out the regulator and the transformer, and then the rest of this will just go in the recycle bin. So I pulled off the parts I'm going to keep: transformer, some transistors, a little micro switch, keep the LEDs, they're always good to have. And let's say I pulled the semis off, even pulled that little crystal out there just in case. The rest of the stuff here is, just basic resistors and stuff. Not going to waste my time to take those off. So we'll recycle what we can. The transformer is always nice to have. It's a little 15-volt transformer, so that'll run down nicely, regulate down to 12 or 5 volts. So it's always nice to have a little transformer. So these parts go in my old parts recovery bin, and the rest of the stuff goes to recycling. I ended up with an MPS 751, which is an NPN VHF oscillator. I got a MPS 651, which that's a PNP general purpose, and I ended up with 4 2N, what are these ones? 2N3924, which are also a general purpose NPN transistor. So overall, I gained a couple of spare transistors for low voltage applications like preamps and so forth. So I think I did okay. Thanks for watching. We'll catch you in the next one.